Today, I'm going to address the problem of figuring out which of your outlets in your house are on the same circuit. And among those that are on the same circuit, which ones are closer to the fuse panel or breaker panel. The primary reason we want to know this is because we may want to install either a ground fault interrupting device or an arc fault interrupting device, or one that does both. That's just a replacement for an electrical outlet that cuts the power when bad things happen. If you buy one of these things, you will get an instruction sheet that looks a lot like this. This one happens to be from Leviton, and it's for both an arc fault and a ground fault outlet, but the instructions are essentially the same. The instructions are really quite complicated in terms of figuring out what fuse your outlets are on and what order they're on. The bottom line is that in order to install your in order to install your breaker, you're going to need to find all of the outlets that are connected to a particular breaker. And you're going to need to find out the order they're in the circuit. Now, this order might be a straight line like these outlets, or it might be a branch like you see this light bulb and switch connected to a branch from one of the outlets. Outlets can be on branches as well. So in generally, we have this tree of wires and outlets, and we want to figure out what the organization is. Just to make this a little bit more concrete, I'm sitting in my dining room, and I can see 4 outlets quite easily that I'll show you. There's 1, there's 2, there's 3, and there's 4. Now, there's other outlets in adjacent rooms that may or may not be connected, but for now, I'm just going to concentrate on the 3 that I showed you. Can I place those outlets in terms of the diagram that I just showed you? Can I say which one is close to the panel? Are they all connected to the same circuit? Which one is closest to the panel? And are they all consecutive, or are they in some kind of a tree arrangement? Now, I'm going to do this without taking anything apart and without flipping any breakers. And I'm going to use about $50 worth of tools to do it. The first tool is something I bought at a dollar store for $1.50. It's just a regular power bar, not fused, not special. Second tool is a space heater. This happens to be a 1500 watt space heater. If you don't have one of those, a hair dryer or a toaster or just about any high heat device will work. And last, I need an electrical multimeter. This one I bought at Canadian Tire. For my American friends, there's not quite such a thing as Canadian Tire. It's kind of a cross between, Ace and Napa and Walmart. Anyway, you can get one of these at your favorite store. You can probably get one on Amazon for about 20 or 25 bucks. So these are the only 3 tools that I need. I need a heater, I need a meter, and I need a power bar. Now, the basic principle here is that when I plug the heater in, it is going to cause a voltage drop at the outlet that I plug it into. And the voltage drop for all of the downstream outlets will be exactly the same. Okay? The voltage drop for the upstream outlets will be less. It will be some fraction of that total voltage drop. So let's go and do it with the middle element, the second element that I showed you. So there's the second element. I'll walk over there with my tools. Let's see what happens. First of all, I'm going to measure the voltage in this outlet. I do that by setting my meter to AC volts, and I have to set the maximum range. It has to be at least 120 because I know that my household supply is 120 volts. Then, if I stick the prods into the two slots, I will get the voltage. But wait a minute, I can't do that. That's because this outlet is tamper-proof. In the US and in Canada, if you ever install a new outlet in a residential building, it must be this tamper-proof variety. And this is to prevent children or adults from sticking metal things in the socket. And it's quite effective. If I try hard enough, I can actually get the two prongs in. The trick is you have to push the two prongs in at the same time. And if you look at the meter, you can see that it reads 119.3 volts. Okay, 119.4 volts. It can't make up its mind between 119.3 and 119.4. That's okay. So it's set at 119 volt, or it's at. This is why I have $1.50 power bar. Instead of trying to fiddle with this childproof lock, I plug in the power bar. The power bar is not childproofed, so I can simply plug in my electrical meter to that. And get a continuous readout. Seems to have fallen to 118.8. There must be some appliance that is connected to this circuit. So it's 118.8, good enough for now. So what happens is, if I plug in my heater, it drops to 115.1. So 118.8 to 115.1 or 115.2 is 3.6 volts. That is the voltage drop. If I turn off the heater, the voltage goes back up. Okay, it goes up to 119. But the idea is the voltage drop here is 3.6 volts. Okay, so let me turn the heater off and let's go to a different outlet. If we see this outlet, it's already got a power bar connected to it. We'll just get rid of that. And we'll plug in the electric meter. And we see it's 119.5. If I go and turn on the heater, it goes down to 116. So 119.5 to 116, 3.6. Well, that's a pretty close call. Let me go back. Okay, 116. Let me go back to my original outlet and see what it's at. It's at 115.2. Okay, so it's pretty clear that even though the difference is not huge, the voltage drop is higher at this outlet than it is at that outlet. And that means to me that this outlet is downstream of that one, only by a little bit. Well, they're only about 8 feet apart, but it is nevertheless downstream. let's move on to the other outlets. Okay, here we are with outlet number 3. The voltage I'm reading on this outlet is 115.7. That's almost the same thing. 115.7. So I don't see any difference between the voltage drop at this outlet and the voltage drop where my heater is plugged in. That indicates to me that this outlet is downstream of the other outlet. Let me go bring the heater here. So now with the heater unplugged, we're back to 119.5. If I plug in the heater here, I see 114.7. So that's the lowest we've seen so far. 114.7 at this outlet. Let's go back to the other outlets. This outlet is showing 115.8, definitely higher. This outlet, 116.6. So now we know that these outlets are pretty much in order. Excuse me, this outlet is closest to the electrical panel. The next one is the second closest, and the next one is the third closest. Now, let me bring in the fourth one. Yeah, I've still got my heater plugged in on number 3. So let's see what happens. Number 4. 116.1, 116.2. So what does that mean? Does that mean that this outlet is upstream of the other outlet because it has a lower voltage drop? Well, it's not quite that simple. Let's have a look at what happens if I bring the heater over here. With the heater unplugged, we're back to 119.5. Plugging in the heater, we see 113.5, a new record low. So this indicates to me that even though this outlet did not appear to be downstream of the third outlet, it is in fact farther away from the circuit. Okay, so now that I've got it plugged in, let's go back to number 3. Here's number 3. And I see 116.5 volts. So how can that be? We have number 3 is downstream from number 2, or sorry, number 3 is downstream or upstream from number 4, yet number 4 is upstream from number 3. The answer is that these are both on separate branches. And so if you follow one branch, you get here, but you go through the branch that leads to the heater. And similarly, if you take the branch that goes down to the heater, you go via a branch that comes here. This is what we can learn from looking at all of the electrical outlets, plugging the load into one and measuring the voltage drop at another. Okay, coming back here to me, let's just briefly talk about what's going on here. If you, let's suppose you have a circuit that goes from 1 to 2, and then directly from 2 to 3. That means that the voltage drop at 1, if you plug the load into 1, the voltage drop at 1, 2, and 3 will all be the same. If you plug in load into 2, the voltage drop in 1 will be less, and the voltage drop in 3 will be the same. And then if you plug it into 3, voltage drop at 1 will be the least, 2 will be the second least, and 3 will be the highest voltage drop. That's what we saw with the first 3 outlets. But if we reprise that with 1, 2, and 4, we see the same. And the bottom line is that 1 is connected to 2, and 3 and 4 are connected to something else that is in common, so that if you go from the fuse panel to 3, it goes through the something else. And if you go through the fuse panel to 4, it also goes through the something else. And that means the drop at that something else is actually going to be less than the drop at 3 or 4, whichever you plug the load into. Okay, that is the teaser. In my next video, I'll get out a piece of paper and I'll outline the theory in more detail so that you can determine by plugging the load and the meter into different outlets precisely how the circuit is wired up.